9:18 in the morning, April 10th, 1963. 220 miles east of Cape Cod, the Atlantic Ocean lies flat and grey under an overcast sky. The submarine rescue ship USS Skylark drifts alone on the surface, her crew gathered around a speaker crackling with static. For the past several minutes, they have been trying to reach USS Thresher, the most advanced attack submarine in the world. Now, somewhere beneath them, in water more than 8,000 feet deep. The last clear message came 5 minutes ago. Lieutenant Commander John Wesley Harvey, commanding officer of Thresher, had spoken personally into the underwater telephone. His words were calm but unmistakable. Experiencing minor difficulties. Have positive up angle. Attempting to blow. Will keep you informed. Since then, nothing but garbled fragments. At 9:16, Skylark's hydrophone operator detected something that might have been the word exceeding, followed by test depth. At 9:17, a final transmission contained only a number. 900 feet below test depth. Thresher was at 2,200 feet and sinking. Then, at 9:18 and 24 seconds, every man on Skylark heard it. A dull, muffled thud, the unmistakable sound of a ship breaking apart. In approximately 1/20th of a second, America's most sophisticated nuclear submarine ceased to exist. Her pressure hull collapsed inward at a velocity approaching 2,600 miles per hour. The energy released equaled 22,500 pounds of high explosive. 129 men, including the commanding officer, 16 officers, 96 enlisted sailors, and 17 civilian technicians and engineers, died before their nervous systems could register what was happening. The Navy would spend the next year searching for answers. They would find the wreckage scattered across the ocean floor at a depth of 8,400 feet. They would discover that the ship they had built to dive deeper, run quieter, and strike harder than anything in existence had been killed by a chain of failures that began with a defective pipe joint no larger than a human wrist. And in the aftermath of the worst submarine disaster in history, they would create something that had never existed before. A system so rigorous, so uncompromising, that in the 6 decades since its implementation, not a single submarine certified under its protocols has ever been lost. This is the story of USS Thresher, the ship that changed everything. To understand what America lost on that April morning, you must first understand what Thresher represented. She was not merely the newest submarine in the fleet. She was the first of her kind, the prototype of a revolution in undersea warfare that would define the Cold War beneath the waves. The Thresher class, later renamed the Permit class after her loss, emerged from a 1956 study called Project Nobska. The National Academy of Sciences, at the request of Chief of Naval Operations Admiral Arleigh Burke, had assembled the finest minds in oceanography, acoustics, and naval engineering to answer a single question. How could America maintain dominance beneath the oceans in an age of nuclear propulsion? Their answer was radical: build a submarine that could dive deeper, detect enemies at greater range, and attack with weapons that had never existed before. The result was USS Thresher, hull number SSN-593. Her specifications read like a wish list from science fiction. Displacing 3,750 tons on the surface and 4,300 tons submerged, she stretched 278 feet, 6 inches from bow to stern. Her beam measured 31 feet 8 inches. A single Westinghouse S5W pressurized water reactor drove twin steam turbines, producing 15,000 shaft horsepower through a single shaft fitted with a revolutionary 5-bladed symmetric propeller. That propeller, combined with the smallest sail ever fitted to an American nuclear submarine, gave Thresher a submerged speed of 33 knots. She could outrun most surface ships while remaining invisible beneath the waves, but her most remarkable feature was her depth capability. Previous American submarines operated at test depths of 700 to 750 feet. Thresher's pressure hull, constructed from HY-80 high-yield steel, with a tensile strength of 80,000 pounds per square inch, nearly doubled that figure. Her test depth was 1,300 feet. Her collapse depth, the point at which the hull would fail, was calculated at approximately 1,950 to 2,000 feet. This was not merely an incremental improvement. It was a generational leap that placed American submarines beyond the reach of most Soviet anti-submarine weapons. At 1,300 feet, Thresher could slip beneath thermal layers that bent and scattered sonar signals, rendering her virtually undetectable. Her weapons matched her capabilities. She carried 4 21-inch torpedo tubes capable of launching Mark 37 anti-submarine torpedoes, and, for the first time on any submarine, the revolutionary Subrock, a nuclear-tipped missile that could strike targets 40 miles away. The Subrock represented a quantum leap in submarine warfare, allowing Thresher to engage Soviet submarines at ranges far beyond the reach of conventional torpedoes. Her BQQ-2 sonar suite, mounted in the spherical bow rather than the traditional keel position, provided detection ranges that dwarfed anything the Soviets possessed. This bow-mounted sonar freed up torpedo room space that had previously been occupied by sonar equipment, giving Thresher both superior sensors and increased weapons capacity. The construction of Thresher at Portsmouth Naval Shipyard was itself a milestone. Her keel was laid on May 28, 1958. She was launched on July 9, 1960, sponsored by Mary B. Warder, wife of Rear Admiral Frederick B. Warder, a decorated World War II submarine commander. The 2 years of fitting out that followed were marked by the typical challenges of a lead ship, as engineers and builders worked to translate revolutionary designs into working systems. On August 3, 1961, USS Thresher was commissioned into the United States Navy, with Commander Dean L. Axine as her first commanding officer. Her complement was set at 12 officers and 95 enlisted men, though this number varied during her operational career. Her motto was Vis Tacita, Latin for silent strength, a phrase that captured both her mission and her method. She would kill silently, from depths her enemies could not reach. The Navy believed she represented the future of undersea warfare. They had no idea how right they were, or how wrong. The 129 men who sailed on Thresher's final voyage were not statistics. They were fathers, sons, husbands, and brothers. Some were veterans of World War II, others had barely begun to shave. Each had a story that ended on that April morning. Lieutenant Commander John Wesley Harvey assumed command of Thresher on January 18, 1963, just 3 months before her loss. At 35 years old, he was a decorated submariner who had graduated from the Naval Academy in 1950 and spent his career preparing for exactly this command. His wife, Irene, and their 4 children lived in a modest house near Portsmouth. On the morning of April 9th, Harvey kissed his family goodbye, not knowing it would be the last time. Lieutenant Commander Pat Garner served as Thresher's executive officer. A Vanderbilt University NROTC graduate from the class of 1953, Garner was known for his meticulous attention to detail and his encyclopedic knowledge of submarine operations. He had turned down a shore assignment to remain aboard Thresher for her post-overhaul sea trials, wanting to see the ship through to full operational status. Among the enlisted men was Chief Engineman Tilmon Arsenault, 36 years old, a World War II veteran who had served on USS Plunger, USS Pomfret, and USS Skate. Engineman Second Class Ronald Bain was engaged to be married. His fiancée had already purchased her wedding dress. 17 civilians sailed with the crew that day. They were technicians and engineers from Portsmouth Naval Shipyard, the Naval Ordnance Laboratory, and various defense contractors, aboard to observe the post-overhaul sea trials. Then there was Lieutenant Junior Grade James Henry, the reactor control officer of the day. Just 24 years old and fresh from nuclear power school, Henry was filling in for the regular reactor control officer, Lieutenant Raymond McCool, who had been removed from the ship after his wife was injured in an accident at home. McCool would later tell investigators that had he been aboard, he would have handled the emergency differently. Whether that would have saved Thresher remains one of the enduring questions of the disaster. These men trusted their ship. They trusted the Navy that built her. They trusted the system that was supposed to protect them. That system was about to fail. By 1963, the Cold War had moved beneath the surface of the oceans. The Cuban Missile Crisis, just 6 months earlier, had brought the world to the brink of nuclear annihilation. Soviet ballistic missile submarines now prowled the Atlantic and Pacific, capable of launching nuclear warheads at American cities with virtually no warning. The threat was existential, and the pressure to counter it was relentless. The American response was to build faster, deeper diving attack submarines that could hunt and destroy the Soviet missile boats before they could fire. Thresher was the vanguard of this strategy, the first of a new generation designed to ensure American dominance in the underwater arena. Behind her, an entire class of submarines was under construction or planned, each incorporating the lessons learned from her groundbreaking design. The stakes could not have been higher. American war planners understood that in any nuclear exchange, the side that could locate and destroy the enemy's ballistic missile submarines would have a decisive advantage. Those submarines, lurking in the deep ocean, represented the most survivable leg of the nuclear triad. If the Soviets could be denied their undersea deterrent, the calculus of nuclear war would shift dramatically. Thresher was the weapon designed to make that possible. Her combination of depth capability, stealth, and sensor performance would allow her to find Soviet submarines that thought they were hidden and destroy them before they knew they were under attack. The Navy was betting the future of undersea warfare on her success, but there was a darker reality beneath the surface of this technological triumph. The American submarine construction program was racing ahead of safety protocols that had been designed for simpler boats. The industrial base that built Thresher was cutting corners to meet impossible schedules. Quality control procedures that worked for shallow water diesel submarines were being applied, without modification, to nuclear vessels that operated at pressures 5 times greater. The pace of construction was staggering. New submarine contracts were being awarded faster than shipyards could build them. Workers were being trained on the job rather than in formal programs. Inspectors were overwhelmed by the volume of work requiring their attention. The pressure to meet schedules, always intense in defense contracting, became crushing. The Navy knew there were problems. Between 1960 and 1963, a disturbing pattern of failures had emerged across the submarine fleet. On November 30, 1960, a 5-inch silver-brazed pipe joint failed on USS Barbel during a test dive near test depth. Seawater flooded into the engine room at a rate that ultimately deposited 350 tons of water into the compartment before an emergency blow brought her to the surface. Only quick action by the crew saved the ship. Similar failures occurred on Skate, Snook, Sculpin, Abraham Lincoln, and Ethan Allen. In May 1961, a 1-inch pipeline failed from a faulty braze on Thresher herself. Admiral Hyman Rickover, the father of the nuclear submarine program, ordered all silver-brazed joints within the reactor compartment replaced with welded joints. But the Bureau of Ships rejected his request to extend this requirement to the rest of the ship. There were approximately 3,326 silver-brazed joints of 2 inches or greater diameter in Thresher's seawater, high-pressure air, and hydraulic systems. Most were never inspected. Many would later prove defective. The Navy was building submarines faster than it could ensure they were safe. Thresher would pay the price for that decision. On April 9, 1963, the morning broke clear and cool over Portsmouth Naval Shipyard. Spring had finally arrived in New Hampshire after a hard winter. The Piscataqua River sparkled in the early sunlight, as 3 red tugboats nudged USS Thresher away from her berth at 8:05. Families gathered along the waterfront to watch the departure. Children giggled at the tugboat whistles. Wives waved until the submarine disappeared around the bend of the river, bound for the open Atlantic. It was a scene repeated hundreds of times at submarine bases across America, so routine that no one gave it a second thought. Thresher had just completed a 9-month post-shakedown availability, an extensive overhaul that included modifications to her main coolant pumps, replacement of several silver-brazed pipe joints, and repairs to numerous systems that had shown problems during her first 2 years of service. The work had been plagued by delays, schedule pressures, and concerns about quality control that were documented but never adequately addressed. Commander Dean Axine, Thresher's previous commanding officer, had written a prophetic evaluation letter on November 16, 1962. "In my opinion," he wrote, "the most dangerous condition that exists in Thresher is the danger of saltwater flooding while at or near test depth." Axine had commanded Thresher during her first 2 years of service and knew her strengths and weaknesses intimately. His warning should have given pause to everyone in the chain of command. A fast cruise simulation on March 31, 1963, just 9 days before the fatal dive, revealed additional problems. High-pressure air-reducing valves failed. Hydraulic hull valves malfunctioned. Ballast tank blow valves did not operate properly. Most alarming, A drill simulating an engine room leak took the crew over 20 minutes to isolate. At test depth, with the reactor shut down, Thresher would not have 20 minutes. The engineering officers knew this. The shipyard engineers knew this. Yet the ship was declared ready for sea. The schedule demanded it. Admiral Rickover's nuclear propulsion program required demonstration of the reactor plant's readiness. The submarine force needed Thresher operational. The Cold War did not wait for perfect maintenance records. During the overhaul, workers at Portsmouth had performed thousands of tasks ranging from routine maintenance to major modifications. Among the most critical was inspection and repair of the silver-brazed pipe joints that connected seawater systems throughout the ship. Ultrasonic testing of these joints had revealed an alarming failure rate, but the testing program was terminated before it could be completed. Approximately 2,855 joints were never examined. The officers and crew who took Thresher to sea on April 9th did not know about these shortcomings. They trusted that the shipyard had done its job. They trusted that the Navy's inspection system had caught any deficiencies. They trusted a bureaucracy that had failed them before they ever left the pier. At 1100 hours on April 9th, Thresher rendezvoused with submarine rescue ship USS Skylark, commanded by Lieutenant Commander Stanley Hecker. That afternoon, Thresher performed a trim dive and a second dive to half-test depth, 650 feet. Both went perfectly. The crew was satisfied. The ship was performing beautifully. That evening, Thresher released Skylark for the night and continued transiting to the deep dive position. The designated location was approximately 41 degrees 42 minutes north latitude, 62 degrees 27 minutes west longitude, roughly 220 miles east of Cape Cod. Beyond the continental shelf, over water approximately 8,400 feet deep, Lieutenant Commander Harvey sent his evening report. All systems normal, weather forecast favorable. Crew in good spirits. In less than 12 hours, all of them would be dead. At 6:30 on the morning of April 10th, Thresher re-established underwater telephone communications with Skylark. The underwater telephone, known as UQC or Gertrude, was the only means of communication between a submerged submarine and the surface. It was notoriously unreliable, prone to distortion from temperature layers and ambient noise. But it was all they had. At 6:35, Lieutenant Commander Harvey brought Thresher to periscope depth and observed the surface conditions. Calm seas, slight swell. Wind from the north-northeast at 7 knots. Visibility nearly 10 miles. Perfect conditions for a deep dive test. At 7:47, Thresher began her controlled descent toward test depth. Standard procedure required stopping every 100 feet to inspect all seawater systems for leaks. The engineers checked pipe joints, valve packings, and hull penetrations. Everything looked normal. At 7:52, Thresher reported, reaching 400 feet. No leaks. At 8:09, she reached half-test depth, 650 feet. Still, no problems. At 8:53, she reported reaching approximately 1,000 feet. Test depth -300, and continuing deeper. The descent was proceeding exactly as planned. The crew had done this before. There was no reason to expect anything different. But something was already wrong. The Navy's SOSUS system, a network of underwater hydrophones designed to track Soviet submarines, was monitoring the waters east of Cape Cod. At 9:09, SOSUS analysts detected an anomaly in Thresher's acoustic signature. The submarine's turbine generators, which should have been producing a stable 60 Hz electrical output, were fluctuating erratically. Something was causing electrical instability in the power plant. Seconds later, at 9:09.8, SOSUS detected the sound of a main ballast tank blow attempt. High-pressure air was being dumped into the ballast tanks in an effort to surface the submarine. The blow lasted approximately 90 seconds, then faded. It had failed. At 9:11, SOSUS detected Thresher's main coolant pumps, stopping. The loss of coolant flow triggered an automatic reactor scram, an emergency shutdown of the nuclear reactor. Thresher had just lost all propulsion in waters more than a mile deep. The crew of Skylark, floating on the surface 200 feet above, heard none of this. They only knew that their scheduled communications check at 9:12 had received an unusual response. Thresher replied using the code word kilo, meaning satisfactory, but there was something in the acoustic that did not sound right. Then, at 9:13, Lieutenant Commander Harvey came on the underwater telephone himself. His voice was calm, professional, exactly what you would expect from a commanding officer dealing with a technical problem, experiencing minor difficulties, have positive up angle, attempting to blow. We'll keep you informed. Those were the last coherent words anyone would hear from USS Thresher. In the control room of USS Thresher, 1,000 feet below the surface, the situation was deteriorating faster than the crew could respond. The most probable sequence of events, reconstructed from acoustic analysis, wreckage examination, and testimony before the Naval Court of Inquiry, begins with a catastrophic flooding incident. A silver-brazed pipe joint, weakened by defective manufacturing and subjected to pressures it was never designed to withstand, failed somewhere in the engine room. Seawater sprayed into the compartment at tremendous velocity, seeking out electrical equipment with unerring precision. The spray found its target. Circuit breakers tripped. Electrical buses failed. The main coolant pumps, essential for maintaining reactor cooling, lost power and stopped. The reactor protection system, functioning exactly as designed, initiated an automatic scram. In an instant, Thresher went from a powered submarine capable of maneuvering to the surface to a 4,300-ton piece of steel sinking into the abyss. Lieutenant Junior Grade James Henry, the young reactor control officer, faced an impossible decision. Standard post-scram procedure required isolating the main steam system by closing valves MS-1 and MS-2. This would cut off steam to both propulsion turbines and the ship's generators, preventing damage to the reactor but eliminating any possibility of using remaining steam for emergency propulsion. Henry followed procedure. He closed the valves. Lieutenant Raymond McCool, the regular reactor control officer who had been removed from the ship, would later tell investigators that he would have delayed that action, allowing residual steam in the lines to provide a few precious minutes of propulsion that might have driven the ship to the surface. But McCool was not aboard. Henry did what he had been trained to do. The only remaining propulsion was the emergency propulsion motor, a battery-powered DC motor capable of driving the ship at roughly 5 knots. At test depth, with the hull compressed and the submarine already heavy from flooding, 5 knots was nowhere near enough to overcome negative buoyancy. Meanwhile, the men in the auxiliary machinery spaces were fighting to surface the ship using the emergency main ballast tank blow system. They activated the system, dumping 4,500 psi compressed air into the ballast tanks to force out water and provide buoyancy. But the air was not reaching the tanks. The emergency blow system had been designed for diesel submarines that operated at shallower depths. No one had tested it for sustained operation at 1,300 feet. As high-pressure air expanded through the reducing valves and conical strainer screens, the Joule-Thomson effect caused temperatures to plummet. Moisture in the air flasks froze solid, blocking the strainer screens within approximately 30 seconds. Tests conducted on sister ship USS Tinosa 9 days later confirmed the problem. The strainer screens were found collapsed and crushed against backup orifice plates. The emergency blow system, the last line of defense for a submarine in extremis, had been defeated by ice. At 9:15, Skylark called down asking, "Are you in control?" No response. At 9:16, a garbled transmission came through. The hydrophone operator could make out only fragments, something that sounded like exceeding, followed clearly by test depth. Thresher was sinking below 1,300 feet. The crush depth was now less than 700 feet below her. At 9:17, a final transmission. Just a number, 900. 900 feet below test depth. 2,200 feet, and falling, then silence. At 9:18 and 24 seconds, SOSUS hydrophones detected a high-energy, low-frequency acoustic event. The men on Skylark heard it through their hydrophone as a dull, muffled thud, followed by the unmistakable sound of a ship breaking up. Thresher's hull had imploded. The implosion occurred at a depth SOSUS analyst Bruce Rule later calculated as approximately 2,400 feet, some 400 feet deeper than the predicted collapse depth. The HY-80 steel had held beyond its design limits before finally surrendering to the merciless pressure of the deep ocean. At 2,400 feet, sea pressure reached approximately 1,070 pounds per square inch. The implosion took approximately 1/20th of a second, faster than the human nervous system can process a sensation. Water jet velocity reached approximately Mach 3.5, or 2,600 miles per hour. The energy release equaled roughly 22,500 pounds of TNT. The 129 men aboard experienced nothing. Death came faster than perception. The hull tore into 5 or 6 major sections. Machinery, equipment, and human remains scattered across the ocean floor in a debris field spanning thousands of square feet at a depth of 8,400 feet. On the surface, Lieutenant Commander Hecker aboard Skylark immediately began emergency procedures. Signal grenades were dropped at 15-minute intervals. Emergency radio transmissions alerted the naval chain of command. An expanding search pattern began, though everyone aboard Skylark knew there was nothing to find. By mid-afternoon, 15 Navy ships were en route to the search area. At 6:30 that evening, Commander Submarine Force Atlantic ordered families notified. Shore patrol officers and chaplains knocked on doors in Portsmouth, New London, and naval bases across the country, delivering the news that every Navy wife dreads. That evening, Chief of Naval Operations Admiral George W. Anderson announced at the Pentagon that USS Thresher was overdue and presumed missing. President John F. Kennedy ordered flags at half-staff from April 12th through 15th. Surface evidence was heartbreakingly scant, an oil slick, yellowish and spreading slowly across the grey Atlantic. Bits of yellow plastic and rubber gloves, fragments of internal insulation, the kind used to lag pipes and equipment, cork particles, nothing that could explain what had happened. Nothing that could tell the searching sailors whether anyone was still alive down there. USS Seawolf, operating in the area, detected acoustic signals that some initially believed might be survivors. For agonizing hours, hope flickered that someone might have escaped into a watertight compartment, might be alive at the bottom of the ocean waiting for rescue. Sonar operators strained to interpret every sound, desperate to find meaning in the random noises of the deep. Investigators would later determine that none of the signals which Seawolf received equated with anything that could have been originated by human beings. The sounds were biological, mechanical, and geological, anything but the rhythmic tapping of men trapped in a steel coffin. There were no survivors. There never had been. At 2,400 feet, in a hull that had imploded at 3,000 miles per hour, there had been no time to escape, no compartment that remained intact, no hope of rescue. The families waiting ashore did not know this yet. For 3 terrible days they clung to the possibility that their husbands and fathers and sons might somehow be alive. Navy chaplains visited homes but could offer no definitive word. The submarine was missing. That was all anyone knew for certain. Missing did not mean dead. Not yet. The search for answers was just beginning. On April 22nd, the oceanographic research vessel Atlantis II detected a sonar contact at approximately 8,400 feet. On April 30th, the naval research vessel Robert D. Conrad photographed what appeared to be Thresher's anchor lying on the ocean floor. The submarine had been located, but seeing what remained would require technology that barely existed. Bathyscaphe Trieste, the Navy's only deep submergence vehicle capable of reaching Thresher's depth. They was loaded aboard USS Point Defiance on Easter Sunday, April 14th, in San Diego. The ship sailed for Boston via the Panama Canal, arriving April 28th. Trieste had set the world depth record in 1960 by descending to the bottom of the Mariana Trench, nearly 36,000 feet down. But reaching Thresher was not merely about depth. It was about finding a needle scattered across a haystack more than a mile beneath the surface. Over the following months, Trieste made 10 dives to the wreck site. The images that came back were both technically revealing and emotionally devastating. Thresher's hull had torn into 5 or 6 major sections, scattered across the ocean floor like the pieces of a broken toy. Debris extended over an area approximately 2,000 feet long and 400 feet wide, covering roughly 33 acres of seabed, pipes, machinery, personal effects. All the detritus of a submarine's life lay strewn across the deep in water, so far down that no human would ever walk among them. The photographs confirmed what acoustic analysis had suggested. The implosion had been total and instantaneous. No compartment had survived intact. No escape was possible. The 129 men had died as one, in a fraction of a second, joined in death as they had been joined in service. In the days following the disaster, the full scope of the tragedy became clear. 129 men had perished, making Thresher's loss the deadliest submarine disaster in history. 16 officers, 96 enlisted men, 17 civilians, each with a family left to grieve without even a body to bury. Irene Harvey, wife of the commanding officer, was left to raise 4 children alone. The fiancé of engineman Ronald Bain never wore the wedding dress she had bought. It remained in her closet for decades. Chief Engineman Tilmon Arsenault, who had survived World War II aboard submarines in the Pacific, died in water so deep his remains would never be recovered. The Navy did not publicize the names immediately. Families were notified privately, given time to process their grief before reporters came asking questions, but the weight of loss was unmistakable. Portsmouth Naval Shipyard had lost shipmates. The submarine community had lost brothers. The nation had lost faith in the assumption that its most advanced technology was also its safest. Memorial services were held across the country. At Arlington National Cemetery, a group headstone was eventually placed to honor all 129 men, but the most appropriate memorial, many felt, would be ensuring that no submarine crew ever faced the same fate. That memorial would take the form of a program called SUBSAFE. The Naval Court of Inquiry convened on April 12, 1963, just 2 days after the loss. Over the following months, investigators examined every aspect of Thresher's construction, maintenance, and final voyage. Their findings were damning. Portsmouth Naval Shipyard had tested only 145 of approximately 3,000 silver brazed joints during the overhaul. 20 of those joints, 14%, failed to meet minimum bonding specifications. Then testing simply stopped. The shipyard commander later admitted he ended the testing program to avoid delaying the ship further. His overhaul report, documenting these findings, did not reach the Bureau of Ships until after Thresher sank. The emergency main ballast tank blow system had never been tested for sustained operation at test depth. The strainer screens that blocked with ice were installed by valve manufacturer Marotta to protect valve seats from debris. They were intended as temporary construction items that were never removed. No one at the Navy had specified that they should be. The reactor restart time, estimated at minimum 20 to 30 minutes from a cold scram, was far too long for a submarine sinking at a rate of approximately 120 feet per minute. Admiral Rickover had authorized emergency use of reactor decay heat for propulsion only aboard USS George Washington. Thresher and other submarines were not covered by this authorization. Admiral Rickover himself testified before the Court of Inquiry. His assessment was blunt. The Bureau of Ships had ignored his warnings about silver brazed joints. Quality control procedures were inadequate. The shipyard had prioritized schedule over safety. The submarine force was accepting risks it did not fully understand, but Rickover was not blameless. His insistence on rigorous reactor training had produced officers like Lieutenant Junior Grade Henry who followed procedures to the letter, even when deviation might have saved the ship. The culture of the nuclear navy, with its emphasis on compliance and its intolerance for improvisation, may have contributed to the disaster. The Court of Inquiry concluded that the most probable cause was a piping system failure in the engine room, which caused flooding that sprayed water on electrical circuits, leading to loss of power and automatic reactor shutdown. With propulsion lost and the ballast blow system ineffective, Thresher exceeded her collapse depth and imploded. No single person was held responsible. The failure was systemic, the product of institutional pressures and cultural assumptions that had accumulated over years of rapid submarine construction. The Navy had built a ship it did not fully understand. The ocean had collected the price. Thresher was not the first submarine lost to peacetime accident, nor would she be the last. The history of submarine warfare is written in sacrifice, in the names of vessels that went down and never came back. In 1915, the British submarine E-15 ran aground in the Dardanelles and was captured, her crew killed or imprisoned. In 1917, HMS G9 was lost with all hands during exercises in the North Sea, probably from an internal explosion. The interwar years saw disasters in the American, British, and Japanese fleets as nations struggled to master the unforgiving technology of undersea warfare. In 1939, USS Squalus sank during test dives off the coast of New Hampshire, settling in 243 feet of water. 26 men died, but 33 were rescued in a dramatic operation that pioneered the use of the McCann rescue chamber. That rescue gave submariners hope that survival was possible even after a ship went down. Thresher would extinguish that hope for deep-diving submarines. In 1944, USS Tang, one of the most successful American submarines of World War II, was struck by her own malfunctioning torpedo and sank in the Formosa Strait with 78 men. Her commanding officer, Richard O'Kane, who had been awarded the Medal of Honor for his aggressive attacks on Japanese shipping, was among the 9 crew members who survived to become prisoners of war, but no accident before or since has claimed as many lives as Thresher. And the circumstances of her loss, attributable not to enemy action or crew error but to systemic failures in construction and maintenance, made her sacrifice uniquely instructive. She had not been sunk by the enemy. She had been killed by the institutions that built her. 5 years later, the Navy would lose another nuclear submarine. On May 22, 1968, USS Scorpion disappeared in the Atlantic approximately 400 miles southwest of the Azores, with 99 men aboard. The cause of her loss remains officially unexplained, though theories range from torpedo malfunction to battery explosion to deliberate Soviet attack. Acoustic evidence suggests an internal explosion followed by implosion as the submarine sank below crush depth. Critically, Scorpion was not SUBSAFE certified. She had deployed without completing required modifications due to Cold War operational pressures. Her commanding officer, Commander Francis Slattery, had reportedly expressed concerns about the ship's material condition before deployment. His concerns went unheeded. The Navy's need for operational submarines in the Atlantic outweighed considerations of safety. The Soviet Union suffered even greater losses. The K-129, a Gulf-class ballistic missile submarine, sank in the Pacific in March 1968 under circumstances still debated. The K-219, a Yankee-class submarine, sank in 1986 after a missile tube explosion. The Kursk, an Oscar II-class submarine, imploded during exercises in August 2000, killing all 118 aboard. In each case, the lesson was the same. The ocean does not forgive mistakes. Technology that is not rigorously maintained and properly operated will eventually fail. And when it fails at depth, there are no second chances. Thresher's legacy was to teach that lesson before it was too late for the American submarine force. The response to Thresher's loss was immediate and sweeping. Within months of the disaster, the Navy established the Submarine Safety Program, known as SUBSAFE. The formal certification criterion was issued on December 20, 1963. A Thresher Design Appraisal Board determined that the basic design was sound, but mandated comprehensive reforms. Silver brazing for C-connected piping joints was replaced with welding. Every weld required mandatory X-ray or ultrasonic inspection. The emergency main ballast tank blow system was completely redesigned. 2 T-handle chicken switches above the ballast control panel now energize electro-hydraulic valves on individual high-pressure air flasks located inside each ballast tank, dumping 4,500 psi air directly into the tanks and bypassing all piping. This provides up to 7 times faster surfacing capability than the original system. Air dryers were retrofitted to eliminate moisture and icing. Emergency propulsion using reactor decay heat was authorized for all submarines. Reactor restart procedures were revised to reduce recovery time. Training programs were overhauled to ensure crews could respond to casualties faster and more effectively. SUBSAFE certification operates across 4 areas. Design certification requires review of all drawings and specifications. Material certification requires traceable quality evidence, tracking every item from raw material to installation. Fabrication certification requires documentation of all industrial processes with objective quality evidence. Testing certification requires comprehensive hydrostatic and operational testing of all systems. A submarine must be SUBSAFE certified to submerge for unrestricted operations to design test depth. Audits involve teams of 20 to 30 people. And any significant compliance issue must be reported to Naval Sea Systems Command Headquarters within 24 hours. The program's effectiveness is its defining legacy. From 1915 to 1963, the United States Navy lost 16 submarines to non-combat causes, roughly 1 every 3 years. Since SUBSAFE's implementation, no SUBSAFE-certified submarine has ever been lost. The only post-1963 American submarine loss was Scorpion, and she was not SUBSAFE certified. SUBSAFE's influence extended beyond the submarine force. After the Space Shuttle Columbia disaster in 2003, the Columbia Accident Investigation Board cited SUBSAFE as a model safety program for NASA. The 2011 Deepwater Horizon Presidential Report similarly referenced it as a benchmark for high-risk operations. 129 men died so that thousands who followed would not. The USS Thresher National Commemorative Monument at Arlington National Cemetery was dedicated on September 26, 2019, more than 56 years after the disaster. The polished stone monument lists all 129 names, alongside an engraved image of the submarine. The 6-year campaign to secure it was led by the USS Thresher Arlington National Cemetery Memorial Foundation under Kevin Galise, with critical support from Senator Jeanne Shaheen of New Hampshire. At Albacore Park in Portsmouth, New Hampshire, a granite and bronze monument dedicated April 8, 1990, bears all 129 names. In Kittery, Maine, a 129-foot flagpole, 1 foot per soul, was dedicated on the 50th anniversary in 2013. Every April 10th, ceremonies are held at these sites and at submarine bases across the country. The submarine community does not forget its own. The wreckage of Thresher still lies on the Atlantic seabed at a depth of 8,400 feet. She is considered a war grave, protected by the sanctity of rest in place. Occasional remotely operated vehicle surveys have documented the debris field, but recovery of remains is impossible and undesired. In 2020, following a Freedom of Information Act lawsuit filed by retired Navy Captain James Bryant, thousands of pages of documents related to the Thresher disaster were finally declassified. A federal judge ordered the Navy to release the long, secret Court of Inquiry records. The documents confirmed what investigators had long suspected. The Navy knew there were problems with silver-brazed joints before Thresher sailed. Quality control had been compromised by schedule pressure. Warning signs were ignored because acknowledging them would have meant delaying a ship the fleet desperately wanted. The declassified documents also revealed the human dimension of the tragedy in ways that official reports never captured. Letters from widows, questions from children who would never understand why their fathers did not come home. The bureaucratic machinery of a military organization struggling to explain the inexplicable. Today, every nuclear submarine in the United States Navy carries the legacy of Thresher in its very construction. Every weld is documented, every joint is inspected, every system is tested to standards that did not exist before April 10, 1963. The SUBSAFE program is so ingrained in submarine culture that most sailors never think about it. They simply assume their ship is safe. That assumption is Thresher's gift to them. The story of USS Thresher is, at its heart, a story about the price of progress. In the early 1960s, America was racing to win the Cold War beneath the oceans. Nuclear submarines capable of diving deeper, running faster, and carrying weapons of unimaginable power were being built at a pace that overwhelmed the industrial infrastructure responsible for ensuring their safety. Corners were cut, standards were compromised, warnings were ignored. And on an April morning in 1963, the bill came due. 129 men paid for the Navy's hubris with their lives. They trusted a ship that should not have been trusted. They dove into waters their ship was not prepared to survive. They died in an instant, not from enemy action, but from pipe joints that were never properly inspected and emergency systems that had never been tested. What distinguishes Thresher from other tragedies is what followed. The Navy did not minimize the disaster. It did not blame the crew. It did not bury the findings in classified reports and hope the public would forget. Instead, it transformed catastrophe into redemption. SUBSAFE became more than a program. It became a philosophy, a recognition that when you send men into environments where a single failure means death, you must do everything humanly possible to ensure those failures do not occur. Every weld documented, every joint inspected, every system tested. No exceptions, no excuses, no shortcuts. The 129 men of Thresher did not die for nothing. Their sacrifice created a safety culture that has protected every American submariner since. In 6 decades, no SUBSAFE certified submarine has been lost. That is their legacy. Not a monument of stone, though those exist. Not annual ceremonies, though those continue. But the simple, powerful fact that the men who serve beneath the waves today come home safely because of what was learned from those who did not. The motto of USS Thresher was Vis Tacita, silent strength. In death, she speaks loudly still. Every sailor who surfaces safely carries that debt. Every submarine that returns to port owes its survival to the lessons written in the sacrifice of SSN-593. The ocean took Thresher, but it could not take what she taught us, and that is the true measure of her legacy.